Hi, it's Janos. This is the channel Real World Audio, and I'm going to do some answering questions. And this is going to be on a particular matter. And let's just try to show my desktop here. Now we're going to see something new. Bingo! Here we are. So this is what I see as a YouTube channel owner. I can look at my unanswered comments section, and here you see Who's Mr. Groove's comment on this video, which is on the interconnect cables that I make, and there I've shown a tweak. There you can see a piece of height and tape added to the interconnect cable, and the purpose of that fight and tape is to provide surplus electrons that will help to facilitate the longevity of that interconnect cable, so to prevent oxidation of the silver within, and also by providing free electrons it also improves the conductivity of silver. Now, Hobbes asked the question, and he said that you can't increase electrons if they are saturated to 100%, and silver is, they have to shed electrons if they increase the amount of electrons. Even with copper, it would be the same. There's no free energy or lunch. And it really made me a little bit to go into this subject and just talk a little bit more, and not just talk but also look, show a few things about like textbook material, and just talk about the conductivity, what electrons are, what happens when there's electricity conducted in a conductor, and how can something affect conductivity that provides free electrons. Well, basically speaking, when we have power running in a electrical conductor, then basically the power is the provision of free electrons. So when you have a battery and you attach that battery to the two ends of a wire, then one end of the battery will be providing free electrons, and those free electrons will be knocking out the electrons inside that conductor, so there will be a transfer of electrons along the path. And now let's have a deeper look into the subject, because it's not just as simple as we have a metal, and we have, maybe let me just change back here. Okay, so it's not just as simple that when we have a conductor and there's current running through it, basically what happens is that the electrons being ping-ponged from one metal atom nuclei to the next one. It's something much more complex. But we imagine this process that there are little ping pong balls, which are the electrons, circling around big watermelons, which are the nuclei, and when that's around each atom. If it's a copper cable, each copper atom. If it's a silver cable, each silver atom. And there's trillions and quadrillions and almost incredible amount of atoms, even in a thin, skinny wire. And all of these are spinning. And when we have a battery connected it, or an amplifier, and it starts to push at one end, so it starts knocking off one electron from around one atomic nuclei, and that bumps into the next, bumps, and each one bumps the electron of the next, and they go one by one. However, that's just a model that we have, and we try to describe a phenomenon that occurs at a really microscopic level, which is just completely beyond our comprehension. But it's not just the size that's really tiny, but the timing is also tiny. So that time that it takes one electron to jump from one atomic nuclei to the next, if that was in our time scale, like let's say if it was like 1 second, if it took 1 second for us to jump, let's say, from one tile to the next, like that, like we take a step, right? If we think like of from an electron's viewpoint, if it's a step to get from one atomic nuclei to the next, and that step, let's say, takes us 1 second to take. If we go and look it from the electron's time standpoint, if that's 1 second, then for us, like for an electron to observe like 1 second in our own time, that tiny time it takes one electron to take that 1 second, and for us, when it's just 1 second, for an electron that would be a time length equivalent to the basically to the age of the universe as we know it in billions of years. So an electron takes within 1 second that many steps that it would take us to take in 13 billion years. So that's why, like, there's the scales where this conductivity happens, and how we try to put it into words and formulate theories and create snapshots. Because even when you use electron microscopy, that's just taking a snapshot that happens in this infinitesimal time scale, infinitesimal size, and you freeze it and try to blow it to our scale. The distortion that the information has to go through to jump through that enormous order of magnitude is just humongous. And during that transition, those scale changes, we basically change the information content of the event. And that's, I think you have heard about Schrödinger's cat, Schrödinger's observations, that when you observe what happens at an atomic level, the act of observation changes what is happening there. So when we try to imagine the world, what happens at the atomic level, and translate into our own universe or own theories and thoughts, we are changing it and we are affecting it. So thereby, the approximations we use might not be the best. However, this is not news to anyone in physics, and these approximations that we learned in elementary school and high school that say that an electron jumps from one atom to the next, that was like true in 1910, 1920. So that type of thinking has been superseded by 100th century of physics that followed since. And actually today, when we are making out any sense of conductivity and apply it to what happens within a conductor, that can be understood by looking at the wave function, at the wave transfer of electricity. So when we describe electrons, if you are describing one single electron, you can think of it as an electron. But when you look at conductivity in a metal, you have to look at the stream of electrons as a wave transfer. So basically a transfer of the energy that happens in specific quantity, in specific frequencies, and it has specific chances, windows of opportunity where it can happen. And why I'm saying that? That's because when you provide uh, a certain opportunities for a conductor, such as heat, such as photons, which is light. And what is photon? That's basically energy. That changes the energy level of the electrons. So the electrons can absorb photons and they can emit photons, and thereby they can gain or lose energy. So that's why light changes the conductivity of a metal, because it is, the photons are being absorbed by the electrons and of the metal lattice, and it's going to change how uh, the electrons can move, and it depends a lot on the wavelength of those photons which are getting bombarded into the metal, and the density of those photons. So how it translates to our real world is that we are not getting tremendous differences. So the conductivity is not going to change in the DC domain much, but it's going to change a little bit in the alternating current domain, and not the whole band, just certain frequencies depending on the wavelength of the photons which are bombarding the conductors. Now, that's about light. Light can affect how a conductor conducts, and that's why when you shine light or LED light or laser light, or like you turn on the lights or you switch off the lights, it affects how your system sounds, especially when the conductors are subject to light. So basically, if you have like transparent cables that I'm using, then basically the silver wires of my interconnect are exposed to light. So it can respond to whether my light is on or light is off. There's a difference in the sound, and that's just not just something psychological, but something actual happening. And also temperature. If you heat the metal, the warmer a metal is, the higher the conductivity it is that of the metal. That's because the electrons and the atoms resonate at a higher energy level, and when there is an electron coming into the system and trying to push the valence electron off the around the nucleus, it's easier to push it. It's kind of like when a person is excited, then you can say whoa, and that person will jump. And if the person is calm and if you say whoa, the person will not react to it. That's the same thing with atoms, that if they are more excited, they are more prone to conduction. And so that's why when you change the temperature of a metal, the conductive ability changes as well. I mean the conductivity. And up to the point when the metal actually starts melting. And when the metal starts melting, that's when the cohesion in the crystal structure starts to break down, and then the conductivity will suddenly drop, because then the individual atoms will have high enough energy to break out away from the crystal lattice, from the metallic structure, and just stay in their own little bubble instead of being part of a conductive metallic structure. Let's see. Maybe let's go back. I had looked up a few websites, and where it is. Here, this is something really simple, and someone asked the question about conductivity, how electricity is conducted. So here we see like how is an insulator behaving and how is a metal behaving, and we see there that this color here there that shows the valence, the electrons in a metal versus an insulator, and when we think of it as a single atom, uh, and and the difference between them, that this is how a single atom is described. So basically the electrons can be at a discrete energy level, and there's no transition in between, there's just specific energies. And now when we have a structure that has a bunch of atoms inside, like trillions of atoms, then because each atom stays at a different energy level, different temperature, different state, each metal has like multiple atoms, and some that are polluting the metal, so basically they lower the purity of the metal, so it has different distinct energy bands for each of the valence electrons. So basically there we get this mesh of valence electrons energy states. And when it's a metal, then the energy level of the valence overlaps with the area of conductivity. Now, when we have an insulator material, the area of conductivity and the area of valence electrons do not overlap. So it means that the electrons are unable to go into a conductive state. And when we increase the energy level even further, then we get to the ionization level. And when it's ionized, then basically the electrons are stripped away from the atoms, from the nuclei, and they are free to travel when placed into an electric field or an electromagnetic field that helps to move them away. So in a metal, the two states overlap, so they can travel, but you see the state between ionization and conduction is much greater than the difference for an insulator. So an insulator, the conduction and ionization is really, really close. And both of it is very far away from the valence states. And what does that mean? It means that the material doesn't want to conduct, and you have to provide huge levels of energy to reach conduction, and it means that will be very close to the level of ionization, which also means in the case of insulator, an insulator breakdown. So that's when the chemical structure is getting altered, and it will not behave as an insulator anymore, so this state will change, and that's when we get electric fires, and that's when people's houses are burning down, because when the insulator of your lines in your wall are breaking down and start to conduct, then there is a good chance of fire of anything that touches them and is able to catch fire. Even the insulator material will catch fire because the matter is getting reorganized from that very high, very energized state. So what else I want to show in this graph here? The continuum of states called the conduction band, where the electrons are not bound to any single atom of the solid. They are mobile. So I really want to focus on this paragraph a little bit. And the fascinating property of these states that it is possible for electrons to respond to an external electric field. These states are called Bloch waves. So what does this mean? It means that the electrons in a conductor, they do not just respond to one electron pushing the other electron, and then it just is becoming a current that is just completely oblivious to anything else that happens in your room. No, not at all. The conductivity in your cable or wire, or in this case my silver interconnect, is extremely responsive to an external electric field, and it can be caused by EMI or RFI, and that will basically the energy that's being conveyed by that external electric field is going to affect the propagation of electrons, and there is going to be a change compared to the natural wave that would travel in that conductor in the case there was no external effect to it. But as we all know, for example, if you have a radio station or even your cell phone or microwave, or just like you have a transformer spewing forth an electromagnetic field of like a 60 hertz strong electromagnetic field, then that external field is going to affect the movement of your electrons, and you are going to hear it as a hum in your loudspeakers. And that's because all of these affect the propagation of electrons, which can be described as Bloch waves. There we go, and we have some physics, how to describe it, Bloch function. Here we see how the energy level is represented of an electron when we think about it as describing it as a function wave, basically, instead of just a particle, because when it's a particle, it's a good theory, it's a good model of how to imagine how it would look like if we were as small as an electron. But to understand what it does is really we have to look at the transfer function of the energy state of the electron. How does it lose energy? How does it gain energy? And what happens when it moves from the proximity of one nuclei to the next one, how the energy states change. And you see with that dotted line, that's just the average energy of the electron that's represented. And when we take into account the trillions and quadrillions of electrons that are, which energy states are added together into the combined current and voltage that we are measuring, this happens at the individual electron level, and this is affected by electromagnetic fields which are in the proximity of the conductor, and it's also affected by free electrons, because if there's any nearby free electrons, such as the free electrons provided by a fight and tape, it's going to change the energy level that the electric field that is interacting with these electrons, and changes the state of the electrons, like how much energy do they carry. Let's see what else I wanted to say. What else? So wave vector. So this is basically quantum mechanics, and if we want to look at how electricity is being propagated, what electricity is, then it's quantum mechanics that really explains what's happening inside the wire, and how that electricity that we generate in a closed system, which would be like our audio. You have a signal that is read out by your source, amplified by your amplifier, and then finally transmitted to the loudspeaker. And now what I was describing here, my interconnect cable. So when we look at it in this closed system, that's what Mr. Hobbes was saying that in a closed system, basically one electron transfers the energy from one to the next, and that's what happens. And if we add an external electron to the mix, we cannot add it because the number of electrons are finite and they are playing musical chairs. So one can only jump to an empty space generated by this closed system. However, the system is not a closed system, and it's an open system, so basically it's also subject to EMI, RFI, and to the static charge generated by free electrons in the area. So when we look at the open system, which is the actual situation when we are listening to music, so our stereo is not in a vacuum, it's in real life, then all of these fields add to it. And how much are they adding? Because we are really talking about effects that are happening at the quantum realm. And you would say that's so tiny that it doesn't affect us. And yes, it's really, really tiny, because the quantum effect on a single electron is very minuscule. But we are here seeing this effect not just happening to a single electron, but the majority of the electrons transmitting the signal. And when it happens to all of them, then it's visible. So it's like, I'm giving you an analogy. Imagine that you are on the International Space Station, and they tell you that watch out, in China there's a huge field, and there's one person, and watch out, can you see whether that person puts on a white hat or not? That's the level of quantum effect we are seeing. And if a single person puts on a white hat or takes off the white hat, you are oogling from the space station, you can't see anything, because the what's happening is too small to see. And if there was only a single electron passed, then in your audio system you wouldn't hear it, because that's at such a low level that you can't hear it. However, when you ask, let's say, 100 million people together on the field, and together put on a white cap, all of them, 100 million, then and then you would be able to see that from the International Space Station, that there's a blob on Earth, maybe like this size, on your field of vision, and boop, it suddenly turns white, and poop, it suddenly, the white disappears. And that's the thing with quantum realm in audio as well. It's because what's happening at the quantum level is happening to trillions and quadrillions of electrons. It is already audible in our life. So after all this long lecture, I'm just giving you an exact description, how you can experience this. Or is it large enough effect that you can experience it? I just tried this out. As you see, I have Python tape on my interconnects, and also Python tape on my loudspeaker cable at the end where it connects to the amplifier, and at the end where it connects to the loudspeaker. And what I did is I have here flashlight. So I turn on this nice flashlight. You can see it shines both visible light and UV spectrum light. And just for like 10-15 seconds, I was literally, I put it on the interconnect at the Python tape and charged the Python for like 15 seconds each. And I did that on the interconnects and on the speaker terminals. And before that and after that, I listened to the stereo, what's happening, what are the changes that I can hear. And the changes were like at the big level, like if I'm looking at, did it become like louder? Is the bass bigger? Am I hearing more high frequencies? No, nothing. the changes were at the very low level. So one thing that was the most striking is that the imaging really changed. So I was watching eventually Netflix, and that's streaming, and it's kind of like a lowish resolution MP3 that's coming through. But even through that, what I could hear is I was watching Stargate, and they were talking to each other, and there was like a scenario where they showed the base, and then there's like people talking in the background. You could hear those talks in the background much more clearly than before. You could hear the ambient space much better when there was like the shuttles flying, the death gliders flying. Before the light shining, I could hear that the death gliders were flying in the front of the room. And after the light shining, the death gliders were flying over my head. So the three-dimensionality is just literally transformed through that effect. And all of these, and then the low level subtleties, and the human voices, they became much more human as well. So the like a little graininess or roughness was gone from there. And uh, and basically, how we could explain it, what's happening there, because when we are shining those electrons, and I mean shining the photons on the phyton, on the titanium dioxide molecules, then because of this extra photon, that will uh, cause an electron from that uh, structure to ping, bounce off, and be available in the proximity of the silver wire. And that will change the conductivity of the silver. It will improve it a little bit, which is another way of saying the resistance went down a little bit. And what happens when there's the resistance drops? It means that you are losing less of the lower level resolution. So the low detail levels are the first that are going to go when there is resistance in your signal path. And when you decrease that resistance, then the low signal level is going to increase. And that's what we expect from the physics of the phyton tape, and from quantum mechanics, and from physics, and that's what we can also observe. So I hope that this little lecture, impromptu and simplified lecture, helps to understand what's really happening, because I haven't seen anyone really explain it in audio, and on the forums when we type away, we just hear like two distinct opinions crashing against each other, that no, this is voodoo, blah, BS, or other people saying no, just go to university, take a 101 level class in electronics, or how conductivity or something, just higher level physics, and it's totally basic stuff. And uh, and we live in an age where people don't even bother to really check the facts. We all pretend that physics is stuck at the state where it was described in 1910, 110 years ago, and people are going at each other's throats on forums because, like, well, we think that that's physics, that's what I learned in elementary school, that's all the universe, there cannot be more. And if you are not willing to face that fact, then then there's something wrong with you. But guys, this is all like a blind man uh, trying to debate a deaf person. Doesn't mean anything, because none of them are have any knowledge about real life facts. And guys, when we look into electricity, how alternating currents, how low-level alternating currents occur, how electric wires that are in your system interact with the electromagnetic radiation, electromagnetic interference that's present in your room. If we don't understand the elementary basics of that, then I don't know. It's just like it's an empty theater, and it's just egos clashing. But when you dig into it, just dig into it, and you will find that what people who are really willing to just look into it instead of just talking empty trash. So when you are willing to look at it, look at the physics of what's exactly happening, and you also use your bloody ears to just experience what's going on, and you link up with people who are willing to take that effort to actually put down something on the table instead of just yakking and saying that I know the truth because I went to high school, and the word ends there. There's nothing more. And everyone who says there is a charlatan. And then they pick up their cell phone, which uses physics that requires a very much higher level of understanding than just electrons bouncing off each other. So I really promote that if anyone is curious about anything, dig into it deep, and listen to things that you hear, and and just experiment on your own. Hook up with people who experiment as well. I had the fortune to meet my mentor, to meet my audio buddies and friends who have gone a long way along experimenting, and as all experiments go, they only have value and worth is when they happen at the environment where you can observe the effect. So if you want to see what's on the other side of the window, if you keep your curtains shut, you won't see what's happening. You have to have those conditions when you are able to observe those effects that are happening. So for example, these effects that I was talking about, like shining a light on the phyton tip and observing, if you have a stereo system that has no low-level resolution capacity at all, it doesn't have any capacity to image in 3D, then don't expect that when you just stick a piece of phyton tape on your interconnect where the conductor is not even visible, not even close to the surface. Of course, there's nothing that's going to happen because the free electrons are not getting any close to the conductor, and then even if they would get close to a conductor, like using a case when I have with my cables, even then you would not notice a difference because your system is not able to resolve it. And then if you write this off that this whole thing is humbug, then all power to you, but it's kind of like a blind man saying that the sky is blue, you guys, fuck F you all, you are liars, I can't see it. uh, it just tells about you, either your unwillingness or your incapacity to see the sky. And uh, and I'm here to teach you how to open your eyes, how to help move towards the procedure or towards that state where you can observe it. Maybe you don't want to observe it. I don't know. I'm not now when I'm saying this, I'm not talking to Hoops because I know he has an open mind. I'm just talking about all of the audiophiles, everyone out there, and the number of those people who really are at home with trolling territory, and who really don't want to improve themselves. They don't want to improve their experiences. They just want to prove one thing, that they went to elementary school and they think that's the end of the universe and nothing can exist beyond that. And I don't know, if you want to get stuck in that level, fine, it makes you happy, do it. Everyone, do what makes you happy. Me, it makes me happy when I am able to experience things and push the limits of uh, our abilities, of what we can experience through sound and music. And I'm not one of those guys who just buys the box based on reviews, and if one is better than the other, I'm happy, and then I'm looking for the next review to buy another one, and then my current box can go into a landfill. Who cares? uh, no, to me that's just that's not my thing. What I really am looking for and doing is understanding how things work, what happens within your components, how do the components interact with each other, how do they interact with the electric fields in your room, with the light in your room, because all of these, when you are at a level of audio that your system is able to resolve low information level, both in a dynamic range and textural range, at that level, these low effects are already going to make a very noticeable change. And you don't need to be a golden ear to hear that. When we had our audio clubs with my mentors too, he, he did that every month for over a decade. And we had everyone in the audio club could hear the difference. And even those who like who did not have golden eyes, they say something is different. I hear it definitely will change. I just don't have enough experience or vocabulary to tell like what's exactly happening, but I can clearly tell this something happened, and it's different. Is it better or not? Maybe. On other occasions, they said, "Oh, this is a very clear, noticeable improvement." Uh, and and but we had like thousands of instances when we were experimenting with quantum level phenomena, and often it's just huge, tremendous. uh, Sometimes it's smaller, but sometimes it's really really big. And even like the total non-audiophile people with almost like hearing aid level, even they can spot that, oh, these things are happening and something is happening in the sound. And so that's it. That's why I have this unorthodox channel, to give you these unorthodox ideas. You might not be hearing about them in any popular media. If you dig in forums, then you might find reports on this, but it's not so easy to find them, and it's not so easy to find any tangible physics explanation, like what's really happening, why are we observing this effect. And now I think I hopefully I had a decent job describing what happens, how electricity is conducted, how it's being affected by electrical fields, um, and I hope it was worth for all of you to watch this little video, and thank you. I hope it works all right. This is the first time I'm making this video on the computer, not on the phone, using this camera and its built-in microphone. So I don't know. I hope it won't be clipping. I hope the picture will be visible, and the instances when I showed this computer screen, they come through. And thank you for watching. Please like and subscribe. It makes a difference for my channel, and not for me, because I'm not making any money out of the channel, and it personally doesn't affect me how many subscribers do I have. It affects my state of mind and my soul to see that what I'm sharing, you are interested in it, and it's not just the interest, but there's use for it. So so far I have received, I think, over hundreds of comments with feedback that you have tried out what I said, and you found the results. positive. It made a good change for you, and the more people subscribe, the more videos you watch, the more chance you get to have positive improvements for your stereo system. And these things that I'm sharing, most of it cost very little money to implement. It's just your effort that you get up from your chair. Instead of pushing buttons to read and watch reviews, you actually start taking action and doing something for yourself, for your life. And basically, this is what real world audio is about: staying in the real world, doing something real for yourself. And because uh, I'm now quoting Arnold Schwarzenegger for you guys, when they asked him what makes the difference between how he is weight training, why does he get result, so much results with his weight training compared to the guy next to him who is still there in the gym, like the same hours, same number of hours as Arnold, but he's nowhere like Arnold. He's just like hardly any muscle development. What's going on? Why is the difference? And he said that it's the state of mind. It's how much focus and energy you invest into what you are doing. If you invest as much energy into something as slamming your toilet door, then that's all the gains you are going to get from it. You are escaping the smell, right? But you are not doing anything positive for you. When your mind and your focus is where you are going, then you will be able to make a difference in your life. And this type of advice is what I'm sharing, and I urge everyone to act on it. You don't need to take all my words given granted, but what I urge everyone is to that I help you start thinking, and that instead of just binging reviews and being a passive element in your audio journey, you get up, you get activated, you start using your brain, and don't let it degrade into cabbage soup, but use the potential you have there and go out, find information for yourself, have ideas, work on them, follow through, try it out. Let's see what works, what fails, draw conclusions, ask other people why did you fail, why did you succeed, and then that's how you can go from step 0 to step 1, step 2, and advance. And that's only happening when you do something for yourself. If you are just binging sound samples, listening to a review, listening to a guy, does he recommend this, what does he say, you go with the recommendation, you reject it, it's not going to make a significant change in your life, in your audio journey. The only thing that's going to make is your brain power. Engage it. So have an awesome day. Engage your brain. Bye bye.